Hi everyone, we're just going to wait a few seconds to make sure that everyone is in this webinar room. I hope everyone is safe and healthy during this pandemic. We would have loved to be able to do this event in person, but hopefully in the near future we will be able to meet everybody again. Okay, I think pretty much everyone is in the room now, so we can start. So good afternoon and good morning to those who are joining us from the Americas. Welcome to WinGD's Power Plant Solutions webinar. Thank you for joining us today. My name is Trianne Hoopshaley and I'm WinGD's Brand and Marketing Manager. Presenting to you today is Luca Sala and Silvio Sala, not related. I'll let them introduce themselves a little bit later. Before I hand you over to Luca, I'd like to go through some housekeeping points with you, as well as the agenda. So all attendees are automatically on mute so that our presenters do not get interrupted during their presentation. If you have a question, please write it in the chat box. You find the chat box to the right of your screen. We will collect all your questions and Luca and Silvia will answer them during the Q&A. If we don't have time to address all your questions, our experts will get back to you at a later date. The presentation slides, as well as a link to this webinar recording, will be emailed to you in the following week. Your viewing screen can be adjusted. If you look under where you can see me, there's a black line. If you move it up, the presentation will become larger and easier to see. Okay, now let's have a quick look at the agenda. So Luca will first introduce you to WinGD and our history. He will then present WinGD's XDF genset, the benefits of our XDF engines over medium speed engines, and our value proposition. He will then hand you over to Silvio, who will present WinGD's power plant solutions covering modularized power plants and the integrated floating storage power unit solution. Well, that's it from me. I'll see you again during the Q&A, and now I'll hand you over to Luca. Thank you.
Thank you, Dan. Good afternoon and good morning for attendees from the Americas. I would like to thank you as well for joining our webinar today. My name is Luca Sala. I'm the product manager for digital solution and portfolio strategy in WinGD. Today, as anticipated by Trianne, I will go through a short introduction on who we are, and after we'll present you the benefit of our XDF genset for power plants application. For some of you, the name of WinGD may sound new to the power generation market. However, we have a long history with two-stroke engines for both marine and power plants application. We started our journey more than 150 years ago as a Sulzer. For over a century, our engines have powered several thousand of vessels and multiple power plants. In 2015, WinGD has been established as an independent company. With the introduction of the XDF technology, WinGD has become the market leader for low-speed dual-fuel engines. Dual fuel means that our engine can burn either natural gas or diesel as main fuel. We are a Swiss company. Our headquarters are based in Winterthur, close to Zurich. In Winterthur, we have also one of our 4 test facilities. The test facilities are very important for us because these are the places where we can test our concepts and validate new technology before rolling out this technology in the market. As I anticipated earlier, we have a long history also in powering power plants with two-stroke engines. Today, we still have more than 800 megawatt power plants running with our technology. These power plants are producing energy in a very reliable way and with a low cost of electricity. Actually, on this point is I would like also to present a testimonial for one of our customers. The low cost of electricity is the key factor that characterizes our technology. Compared to medium speed genset, our XDF can have up to 8% lower fuel consumption and higher intervals between overhauls. Overall, these two factors contribute to keep the production cost of our XDF lower compared to a typical medium speed genset. With that, I would like now to start to speak more in details about our XDF technology and the benefit that our technology brings to the power plants business. As you can see from this chart on the left of the slide, our XDF are going to fill a gap in the current market for the power generation. We position our technology in the middle between the very high efficient combined cycles, but less flexible solution, and the very flexible solutions such as open cycle gas turbines or medium speed genset, but less efficient compared to a combined cycle. So our opinion is that the XDF genset brings the right combination between efficiency and flexibility for power plants to produce energy with a low cost of electricity and at the same time a low emissions. The key enablers to achieve this target are, in first place, the high efficiency we provide across all loads. As I will present in a couple of minutes, at low load, our efficiency is still above 45%. Compared to gas turbines or medium speed genset, we have lower maintenance cost. Compared to the medium speed genset, one key advantage that we provide is the fact that we do not require any after-treatment solutions such an SCR system and a CO catalyst to operate our genset within the European regulation in terms of NOx and CO emissions. This means we do not need urea to control the NOx emission, and this has a positive impact on the operating cost of the power plant. Our portfolio for power plants application includes genset from 15 megawatt up to 40-45 megawatt. Based on the project-specific requirements, we can configure the right engine for the project. We can tune the engine based on power output or efficiency depending on the project-specific requirement. We are available to conduct any specific study to provide you a data sheet with the key information. So don't hesitate to reach us for further question or clarification on possible project you are evaluating. Now, I present in these slides our efficiency curve. As you can see, we have a very high efficiency. Actually, our efficiency is the highest among all the open cycle technologies if you compare this curve with a typical medium speed genset and open cycle gas turbines. In particular, if you look at the low loads between 30, 40, 50%, our efficiency is very high. We speak about more than 45% efficiency. This represent up to 6% points higher efficiency compared to a medium speed genset. The high efficiency, and in particular the high efficiency in low loads, is very well suited for old power plants operating in island mode and for power plants that provide a large spinning reserve to compensate the fluctuation of renewable in the grid, or even for industrial application where a certain degrees of spinning reserve is always required from an operation point of view. When we look at the emissions, there are two aspects I would like to highlight today. The first one is related to the NOx and CO emissions. Compared to typical medium-speed genset, our XDF do not require any after-treatment system to operate within the European limits in terms of NOx and CO. As you can see, we can operate below 75 milligrams per normal cubic meter in terms of NOx and below 100 milligrams per normal cubic meter in terms of CO. This means we do not need urea, as anticipated before, to control the NOx. And this brings an advantage from an operating point of view because we will have less operating costs compared to medium speed genset. If we take, for example, a 200 megawatt power plant, by selecting our XDF, it's possible to save more than 1 million euro per year by avoiding the use of urea. The second aspect related to emissions that I would like to highlight today is the fact that our XDF have 2 times lower methane emission compared to medium speed genset. We all know that the methane emission have a higher impact on our environment in terms of greenhouse gases. For example, 1 kilograms of methane in the atmosphere is equivalent to 34 kilograms of CO2. In WinGD, we are committed to further develop our technology to offer you the lowest methane emission for both marine and power plants application. I would like to conclude now my presentation with a typical value proposition, comparing 2 power plants with the same size, let's say 100 megawatt. One power plant is equipped with our XDF genset, and the similar power plant in size is equipped with a medium speed genset. The advantages that I highlighted before, the high efficiency, the low maintenance cost, the low operating cost linked to the fact that we do not need urea to control the NOx emission, are translated into a lower cost of electricity. Assuming the operating profile you see in the table on your left side, we can achieve up to 17% less cost of electricity. On average, it means $44 per megawatt hour compared to $52 per megawatt hour on average for a typical medium speed genset. Such 17% lower cost of electricity for this particular operating profile can be easily translated into up to $6 million per year in overall saving from a power plant's owner perspective. The high efficiency that we discussed in the previous slides is translated into low CO2 emission. In this particular case that we are discussing, it means 17% lower CO2 emissions compared to a typical medium speed genset. These are the 2 main takeaways I would like to bring to you from this presentation. With this, I conclude my presentation on the benefit of the XDF genset for power plants application. I will hand over the presentation to my colleague Silvio. He will present you more details about our modular power plant approach. Silvio, the floor is yours.
Welcome to the WinGD Power Plant webinar. This is Silvio Sala and I'm responsible for the Power Plant product line here at WinGD. Luca has just explained what we can offer in regard of the product features and the relevant benefits. I will take care of explaining how we have addressed the part related to the practical implementation by means of the land-based modular power plant design. To start with, I'm going to share a video illustrating the main characteristic of the modular power plant, and then we will proceed with a brief tour into the basic building block of the plant. In the last part of my presentation, we will review a different LNG to power solution, this time revolving around a standalone floating unit embedding a combination of LNG storage and power generation. Let's start with the video. Hope you enjoyed the video. The modular power plant has been conceived as a pre-designed combination of several key packages. In a certain way, conceptually, the modular power plant resembles to a scaled-up Lego kit. This overarching design criteria has been adopted to simplify the number of interfaces and reduce dramatically the design and construction time. This ultimately led to a lower turnkey cost compared to a bespoke design. Let's zoom into the modular power plant layout and see in more detail how the power module looks like from a mechanical and electrical standpoint. The core of the power generation shown here is a 21 megawatt genset, which is made up of a WinGD 9X62DF engine and the relevant generator. Along with the genset, we can see the accessory rack, embedding the cooling equipment, the ICER system dedicated to the exhaust abatement, the starting receiver for the engine starting, and the centralized lubricant storage system. Of course, the genset power rating can vary as a result of the project-specific plant configuration study, but the overall concept here explained remains the same. Further on, we will review individually the most critical mechanical packages. Also, from an electrical standpoint, the modular design has been conceived to seamlessly integrate the key electrical equipment, such as the low and medium voltage switchboard, transformers, black star generator, neutral ground resistor, UPSs, etc. Typical time-consuming tasks such as cable sizing, bill of quantity calculation, and equipment specification are greatly simplified thanks to the pre-engineering solution. This provides a solid baseline to any PC to start with for a first-pass cost evaluation and any further customization if needed. The plant electric and control architecture has been designed to operate both in parallel with the mains at a given fixed power set point or in island mode following the consumer load demand. Thanks to the large inertia built into the rotating part of the WinGD genset, a large kinetic energy is stored in the system, which makes our solution well suited for grid stabilization in case of high renewable energy penetration. Back to the mechanical modules. Let's look in more detail the engine cooling auxiliaries. They are hosted in a module named Accessory Rack. This module has been designed to integrate the engine pumps dedicated to the low and high coolant temperature circuit, along with the respective thermostatic valve, filters, etc. In particular, the module depicted here is designed for sea or freshwater open loop cooling. A closed loop cooling system adopting a dry cooler is also available. On the same skid, we can find the lubricant pump and the plate heat exchanger to cool the engine lube oil. A set of pressure and temperature sensors are also foreseen in the design to monitor and control the engine fluid cooling loop. A single electric point of connection is also implemented by means of a local control panel mounted along the skid to connect the accessory rack to the plant power and control network. The accessory rack dimension and weight enable its transportation by means of a standard 40-foot high cube container, reducing the overall logistic cost. As I mentioned before, the genset cooling system has been designed to be suitable for a closed-loop circuit. In this particular application, a set of V-shaped dry coolers are located on the genset module roof to limit the overall plant footprint. The dry coolers are equipped with a variable speed fans. The cooling airflow is automatically adjusted based on the ambient temperature. This control logic consents to save a fairly amount of energy drawn by the radiator across the year. The control and drives of each dry cooler fans are implemented by the dry cooler panel, while the generator control panel provides the enabling commands and continuously monitors the status of each fan. Another key item is represented by the ICER, which is the acronym for Intelligent Control by Exhaust Recycling. The purpose of the ICER is twofold. The first one is to reduce the amount of NOx and CO pollutants in the atmosphere without the urea consumption burden. The second one is to enhance the engine internal combustion stability, reducing the fuel consumption and, at the same time, enabling the power plant to operate under a wide ambient temperature range without any derating. The ICER system comes completed with the engine air intake filter, the exhaust silencer, exhaust gas diverter, and the supporting framework. Also, the ICER tower subassemblies can be transported on site using standard ISO container. The genset module ventilation path has been designed to ensure a very efficient radiated heat removal and avoid hot pockets. The fresh air is drawn on both sides of the genset room, and it's evacuated through the outlet box fitted across the roof. The higher inlet boxes included a filtration chamber provision should the plant being operated in a dusty environmental condition. Both the air inlet and the outlet boxes are designed with louvers and dampers to seal the genset room in case of fire and avoid the dust ingress while the genset is standstill. The ventilation boxes are conceived to easily accommodate project-specific requirements in regard of noise attenuation and environmental conditions such as dust, proximity to the sea, etc. The genset module ventilation flow is automatically regulated to keep a constant preset temperature inside the genset hole. The genset and the associated auxiliaries are monitored and controlled by the Generator Control Panel, hereafter called GCP. The GCP is the brain of the genset and represents the single point interface between the genset and the plant automation. During the normal plant operation, the GCP is set in remote mode and it manages the genset start, stop, and synchronization to the medium voltage bus upon receiving a command from the Power Management System or PMS. In this mode, the GCP acts as a slave and the PMS is the master control. The PMS determines which genset of the power plant fleet must be online and its respective power set point based on several factors like the consumer demand, the amount of spinning reserve, and the redundancy needed. The GCP can be set in local mode in order to carry out the genset maintenance or troubleshooting without disturbing the plant operation. The GCP is designed to be remotely monitored by WinGD for predictive maintenance and remote diagnostic. WinGD power plant solution not only comprise a pre-designed package as described so far, but also include a broad range of services to support any EPC during each stage of the project. WinGD support starts from techno-economical advisory to select the most convenient genset configuration and span up to the long-term service agreement. WinGD has established a partnership with some of the most prominent EPC in order to provide turnkey solution if required. Despite the great effort devoted by WinGD in the land-based modular power plant, we acknowledge that the project execution on time and on budget is not trivial. Civil work, permission, logistic constraint, testing, just to name a few, are all tasks which are on the critical path. This can be further exacerbated in remote areas due to the lack of skilled personnel and access to construction material. From an investor standpoint, the onshore plant is furthermore considered very little liquid asset. It inherently a non-movable asset, rendering the project financing subjected to a relatively high interest rate. For this reason, WinGD and H&Z Shipyard, both belonging to the same CSCC group, decided to develop a standalone floating LNG to power solution to gradually reduce the overall project risk profile and offer a self-contained one-stop shop unit. In this horizontal integration, the best know-how of the two companies has been combined. WinGD XDF engine, superior technology, and the HZ solid LNG construction track of record has come together in the form of the floating LNG storage and power unit. The unit shown here is the first of its kind to produce 200 megawatt and store 200,000 cubic meter of LNG to ensure about 4 months of autonomy at 85% of the rated power without any LNG resupply. The floating storage power unit, in summary, provides the following value proposition. It's fully tested as a system at the shipyard, so it is fast to be deployed and delivered anywhere in the world. It complies to stringent EU emission standard without the usage of any urea. It fully complies to the local grid code. The WinGD genset offers high electric inertia, providing optimal support to stabilize grid system with high penetration of renewable energy. It's highly reliable due to 4 independent engine rooms with dedicated step-up transformer. All common services are also duplicated to avoid single-point failure. Gas provision from gas regasification could serve the onshore consumer and feed the local gas grid if needed. Liquid backup fuel provision is also foreseen in case of gas supply shortage as well. It's suitable to be deployed in shallow water, mooring deeper than 10 meters. In January 2021, the Design in Principle certificate released by BV Bureau Veritas confirmed the validity of the 200 megawatt unit design concept. Thanks to the flexibility of the design, other power rating output and LNG storage capability can be accommodated on demand. Hope this short tour about WinGD power plant solution has raised your interest and has widened the thermal power option you have typically considered so far. Of course, we just scratched the surface of what WinGD can offer, and we are happy to work together with you to find the best solution for your next power generation plant. Whatever onshore or floating power generation, we have a solution suited for you. To recap and conclude my presentation, WinGD takeaway points can be summarized in the very attractive solution to achieve the lowest levelized cost of energy, high efficiency and low emission, low maintenance cost, no need for urea to comply with the EU emission regulation, and a ready-to-go solution thanks to the modular and pre-designed solution for both land-based and floating LNG to power EU application. In particular, the floating storage and power unit is fully tested at the shipyard and provide a plug-and-play solution ready to be deployed and connected on-site. With this, I turn over the presentation back to Trian to open the question and answer session.
I am going to also ask Luca to come back and join us so he can answer some questions as well. I see we've got a few questions here, but let's just start from the very first one. So this one's for you, Luca. What is a typical startup time for the engine?
Our startup time is approximately 15 minutes. In my opinion, is the right combination between efficiency and flexibility, looking at the other technologies available on the market, as we discussed in the presentation.
Great, thank you. This one, I think this one's for you, Silvio. What is a typical delivery time for a full EPC power plant?
Thanks, Trian. This question, of course, is very much related to the kind of project, but I would say that we go from about 18 to 24 months as an average, let's say.
Great, thank you. Another one for you, Silvio. What is your instant load capability to support fast load variation in industrial application, for example?
Okay, another good question about genset performance. So the genset can provide a maximum instant load increase or decrease depending on the actual operating load. I would say typically we can provide instant load variation up to 25%.
Great. One for you, Luca. Do you also provide hybrid solutions to better support grid systems with high share of renewables?
Yes, we can provide a hybrid solution. In particular, we can deliver together with our genset an hybrid control system that has been already developed for the marine application. And the hybrid control system allows the coordination of different loads contribution in order to achieve a predefined outcome in the grid in this case. So the hybrid control system will be able to coordinate the engine and a battery system if foreseen by the project.
Great, thank you, Luca. Another one for you, Silvio. What is the typical delivery time for a floating power plant?
It's around couple of years, 24 months as a indicative, let's say.
Okay, good. This one for you also, Sylvia. You showed power plant references on islands. Can you also operate for long periods of time with diesel as fuel? In this case, do you need an SCR system?
That's an interesting question. Yes, of course. Our generators are dual fuel by definition, let's say. So this means that they can operate either in gas or diesel mode. In case of diesel mode, we may need any other technology, an SCR system, depending on the project-specific regulation.
Good. Also, you, Sylvia, could you provide an indicative EPC price?
This is a good one. Okay. It's a difficult question. Of course, there are so many variables, but I would say that the full EPC scope Turkey, let's say, cost can range from $900 to $1,000 per kilowatt installed.
Great, thank you. Let's have a look. Okay, there's another question. What are the differences between low speed and medium speed when operating with solar PV? For you, Silvio?
Also, this one is very interesting. Okay, typically in what is called hybrid power plant case, while you have a PV photovoltaic generator online, the genset need anyway to be able to quickly compensate the drop of renewable, which can happen because of clouds passages or any other bad atmospheric condition. The prompt response of the thermal generation part is vital to keep the grid stable and avoid unwanted outages. Unfortunately, to get a sufficient spinning reserve, the gensets have to operate at partial load, away from their best efficiency working point. In the case of medium speed engine, the penalization to the plant overall efficiency due to high spinning reserve is much higher than our low speed, since our engine provide a fairly high efficiency, also at low load. The WinGD genset are also an additional energy buffer built into the design thanks to the large kinetic energy stored in the rotating part. Just as an indication, a 20 megawatt WinGD genset can store 5 to 6 times more kinetic energy than the equivalent medium speed genset. This makes the WinGD genset well suited for the integration with renewables.
Great, thank you for that answer, Silvio. I think this one is also for you. How small piece engines can be dismantled to tackle problems with logistics in case power plant site is not reachable through water? How long will dismantling and rebuilding take?
This is for me?
Yes, this is for you.
Okay. We have what we call dispatch pattern. The dispatch pattern is a study to address, let's say, different logistic constraint. So the engine, which is the big bulk that have to be transported on site, can be dismantled in a way that it can be, let's say, transported on land if needed. We have already faced this problem. Of course, is not something that can be packaged in an ISO container, but we have studied a different level of disassembly to be able to bring the heaviest component on side of the engine. So again, project by project, we can break it down the engine in a way that is transportable and can be reassembled outside. Beside of the engine, the other balance of plant, as explained before, the electric and mechanical balance plate has been studied to be easily transported on site using a standard ISO container.
Great, thank you, Silvio. This one I'm going to give to you, Luca. Which cycle is used in the XDF genset combustion? Is it diesel or Otto cycle?
That's an interesting question. Actually, we have both cycle inbuilt solution in our XDF. This way, it's a dual fuel engine, so we can operate with diesel and or gas as a fuel. When we operate in gas, the gas is admitted at the middle of the cylinder, and we use the Otto cycle. When we operate in diesel, the diesel is injected at the top of the cylinder, and we use the diesel cycle to operate.
Thank you, Luca. This one, I'm actually not sure who will answer this one. How does XDF solution compare with CCGT or low speed in terms of capex, say 1 megawatt installed?
Yeah, if you want, I can take.
Yes.
Partially was already addressed by Silvio in the previous question. So if we look to medium speed or like gas engine in general, the delta in capex is, let's say, around 10, maximum 15%, but typically 10%. With combined cycle, it's a little bit more difficult because we need to distinguish between a small combined cycle where the capex could be 20%, and compared to bigger combined cycle, let's say 600, 1000 megawatt block, in that case, the capex could be much higher. However, as I presented in the previous slides, it's important to look at the operating profile and where the efficiency and the maintenance cost will pay back the investment much faster, even if the initial capex are higher.
Thank you, Luca. This is also for you, Luca. It has been mentioned that WinGD solution is dual fuel gas and diesel. So does that gas include LPG?
Don't burn LPG as a standard fuel. We have standard fuel specification for every single project. We can review the specific fuel specification, and we can assess if it's within certain limits or not.
If I may add something that maybe is, let's say, out of the standard medium speed requirement, XDF engine can burn gases with a meter number of 60, above 60, which is typically a limit for medium speed engine. So we have, let's say, the capability to burn gases that are not, let's say, completely compliant to the typical grid gas that you find in the Western countries, let's say.
Great. Thank you for that answer, gentlemen. That's all the questions we have so far. I just want to remind our attendees that should you have further questions, you're welcome to send an email to the email address that you see on your screen at the moment, so powerplant@wingd.com. And Luca and Silvio will be happy to answer all your questions. So with that, I'm going to close off this webinar. Thank you, everybody, for joining us. Thank you, Luca, and thank you, Silvio, for presenting.
Thank you, Trian. Thank you, Trian. Enjoy the rest of the day wherever you are.
Thank you. Yes, everyone, all the same. Thank you. Bye.
Bye.